Okay, so for problem number 1, we are trying to find the top section of the tower, which is X right here. So first what I would like to do is I would like to split it up again. So I'm going to make the bottom section Y, and then I'm going to make the full thing A. So we have 87 feet right here, which is adjacent, and we're first going to find the full thing first. So to find that, we're going to use tan 40 equals A over 87. We're using 40 because it's the full angle right here, and then 87, we have that right here, and we're missing A. So with all of that, once you multiply that, it should be A equals 73.002. And now we're going to be finding Y of the bottom, which we're going to be finding tan 25 equals Y over 87. We're using the 25 because we need now to find the bottom one right here. And we still have the 87. And now we're missing the Y. So when you add all or multiply that all up, it should equal 40.569. And to find X, now we're going to subtract both A and Y. So it's going to be X equals 73.002 minus 40.569, which should equal roughly about 32 feet. So 32 feet is our side of X. Okay, so for number 6, we're going to be using this equation to find the maximum height of the diver, the height of the diving board, and how many horizontal feet does it when he hits the water. So first, we're going to need to solve our f of x. So that is going to be the equation y equals negative b over 2a. And to solve for that, we're going to need to break this up into a, b, and c. So that would leave us with negative 24 over 9 all of over 2 times negative 4 over 9. So then to divide that, you're going to need to multiply the denominator by the numerator. So it's going to equal negative 24 over 9 times 9 over negative 8. And we can cross multiply these two, which will be 1 and 1. So it's going to be negative 24 over negative 8, which will equal 3. Okay, so now we're going to plug in the 3 into the equation we originally had. So it's going to be f of x3 equals negative 4 over 9 times 3 squared. And then it's going to be plus 24 over 9 plus 12. So since these multiply would be 9, those would cancel each other out. Times 3, that'd be 3. So it would be negative 4 plus 8 plus 12, which will equal 16. And then our final point would be 316, which means our max height of the diver is 16. Okay, so now we need to know how many horizontal feet until he hits the water. So we're going to use the same equation, but now we're just going to set it to 0. So 0 equals negative 4 over 9x squared plus 24 over 9 plus 12. And so first we're going to need to get rid of the fraction. So we're going to multiply everything by 9, and 9. So then that will be, cancel that out. So it'd be 0 equals negative 4x squared plus 24 plus 108. So now we're going to factor it out even more. So now we're going to take the negative 4 out of the equation. So it'll be x squared minus 6x and then minus 27. And so now what we're going to do is we're going to use the x method. So negative 27 and then negative 6. So that would be negative 9 and 3. So then now we have that. So it'd be negative 4, x plus 3, and then x minus 9. So our x's would be -3, and 9, and 0. So that means our horizontal feet equals 9 feet. So 9 feet there. The max height 16. And so now we need to find how high the diving board is, which it tells us right here is 12. So height of diving board is 12. So here is a graph to help map everything out. So right here is the max height. Here's where the diving board is. Here is the 3, which is vertex, and then the 9 is where he lands. Okay, to solve number 8, we need to write a function that represents the volume of the new bin. So to solve for volume, it is going to be v, or x, equals the number that we are given, so that would be 5, and then times the length, and then times width, and then times height. So now that we know that it's 5 times, we're going to make it 5 on the outside, length, width, height. So that will be our function that represents the volume v of the new bin. So now we need to solve. So now that we know it's 5, to solve, we're just going to do Vx equals 5, and then times 2, times 3, and then times 4. So using PEMDAS, we have to solve parentheses first. So it's going to be 6 times 4, which is 24, and then times 5, which is going to be 120. So the dimensions of the new bin is going to be 120 feet cubed.